Hey guys, Chris Ray here. I just have a quick video for you today. This isn't the normal type of video that I make, but I just got done watching a video called Is Water Wet? The Final Experimental Proof by the Action Lab. Now, I thought this was pretty interesting. I just finished my first year of college here, and in one of my classes we were talking about this, is water wet? And everyone seems to have their own differing opinions and reasons of why it is and it isn't. Some people got mad at me in the debate because I didn't give the most conclusive answer, and that's sort of the same way with the Action Lab, but I think he got a lot of things right, and the end of his video he got something wrong. So if you didn't watch that video yet, I suggest you go check out his video and then come back here to hear my feedback on it. Okay, so assuming you guys went and watched that video, you can actually see on my whiteboard back here, I just have a little representation of water. You have all the water molecules floating around together like what you would find in a glass of water. And whenever you watch the Action Lab's video, I think he took a really interesting take on it about the stuff suspended in the water and how because of that it makes it wet. At the end of his video, he mentioned if you could ever find a way to have completely pure water, then with his theory, that wouldn't be wet. He also said in the video that that wouldn't be possible because you always have things in the water. You can never get pure water. And in my opinion, that's not true. My point to this picture back here is this center molecule that I drew with the 2 hydrogens and 1 oxygen. If you took a single molecule of water and put it on something, that water would not be wet. Both with his description and the way that I described it, that I consider something to be wet whenever it's in contact with water. If you have one water molecule by itself, it's not in contact with water. So that's how I would explain, is water wet or not. Usually, if you see it in a glass, yes. But, you know, maybe with steam or small amounts of condensation, whenever you just have one molecule by itself, whether it's done in a lab or in nature, I would say that water is not wet. Wet to me is whenever you're, like I said, in contact with water. So that's just my take on it. I mean, this isn't a very scientific question. You can also talk about surface tension, and if something's wet that way, like that spray that you can buy that makes water bead off, could that ever be wet because it's hydrophobic? The question doesn't matter, but people really seem to form strong opinions about it. But that's just my take on it. You guys can decide for yourselves, but I hope if any of you watch this video after watching the Action Lab, you can understand what I'm saying and understand that it would be possible to have one molecule of water and that would not be wet. Anyways guys, thanks for watching. I'm Chris Ray. If you liked the video, make sure to hit that like button. If you want to see more videos, probably not like this, but other videos, then get subscribed, and I'll see you guys next time. I almost forgot. In his entire video, he's talking about the toilet paper being what's wet. And then after he adds a bunch of water, he switches that and says that's why water's wet. And I'm not sure if that really works there, talking about how wet the toilet paper is, but then saying that the water's wet because of that. Pretty sure that's not how that works, but like I said in my video, the way that I see it, the definition of wet is when something's in contact with water. So if water is in contact with water, it's wet. If it's not, it's not wet. That's just the way that I see it, and I thought I should point this out here. I almost forgot, but I think that's some kind of fallacy or something where that just gets switched around. Maybe fallacy isn't the right word, I don't know. But anyways guys, there you go.